Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day to each and everyone. So this is Sir Hanif and this is E224. The description of this subject is electromagnetism. Okay, so which will be the first one of the first majors that we have in AE. Okay, so I have not yet given you a orientation regarding on this subject, but I am assuming that you have already your orientation with your different subject. The rules and regulation of your subject you have is practically the same with mine, okay, in this subject. Okay, so please apply it also to this subject, no? So but the only thing that I'm pointing out here regarding on the instructions that we have here in this subject is for the percentage and the passing rate that we have in this subject. Okay, for the prelim or the first exams, we have 20%. The second exams, which is the midterm, is 20% also, and for the third one, which is the final, is uh, 30%. Then the remaining 30% for the quiz is 20%, and for the attendance is 10%. Okay, then the passing rate we have here is 60%. Okay, so please do your best to reach that passing rate. Okay, so once again, this is electromagnetism, no? So what we'll be having here is the application of um, different electrical quantities, no? That can be used in dealing with the machines or the applications in higher majors in EE. Okay, so basically we'll be tackling about the electric field, magnetic field, okay, their application, okay, and how can they generate, okay, um, how are they dealing with when it comes to application of electrical system. Okay, so the first topic that we'll be having is vector analysis. So um, this manual here that I would represent on you is not in mine. No, I just have this as credited to owner. No, uh, please don't share this. No, um, this is just for the learning purposes. Okay, so once again, this is not my own. No, hindi ako yung gumawa nito. So, but since we have the same topics, no, with this manual, so I decided to use it na lang. Okay, so please refer on it. Okay, and don't share this. Okay, so we have here a vector analysis. No, so first is we are dealing with vectors. Okay, so we will first go to the vector algebra. So we have here vector operations. We have a for vectors, no, we know that the vectors are quantities that have both direction and magnitude. The examples are velocity, acceleration, and force and momentum. For scalars naman, those quantities that have no magnitude, that have a magnitude but but without direction. So examples are mass, charge density, and temperature. So if you have a for vectors, no, uh, if we have a three vectors that are being added, we have first is 3 meter and the other one is 4 meter here. Then if you would add that one, the resulting is 5 meter. No, so as you can see here, this 5 meter is not in the same with the addition of the magnitude of these 3 and 4. So it means that this is a vector. Okay, it's because we consider its direction first before we add them. No, so we have here 3 plus by using a Pythagorean theorem, we can find that this magnitude here is 5 meter and its direction is along um, at some angle with respect to this 3 meter. Okay, so this is a vector. But if we assume that these are scalar, for example, these 3 meters are scalar, which we where its direction is not considered, and this 4 meters also is scalar. If we add them, the result would be 4 plus 3, so that is 7. Okay, so that is the difference between the two quantities. Okay, so we have here a notation. So we have for the uh, A and B. Okay, uh, this is type written, no? So we have, if makakita kayo ng ganito, okay, this is a vector, no? But in a handwritten, you can just put arrow on top of it to identify that it is a vector. Okay, and for its magnitude, just place a absolute value, okay, on its quantities to suggest that it is a magnitude. Okay, so for the vector operation, so addition of two vectors, if you have two vectors a and b, if you will add them, just connect the tip of the other vectors into the tail of it, and connect the uh, tail to tip of the other one. Okay, then the resulting is the addition of two vectors. For example, is yung a and b mo, yung tail ng b mo is connected to the tip of a. Okay, then connect the tail of a and the tip of b, then that vectors that is formed is the addition of two vectors. Okay, so yun. So we can also do a um, reversing path, no? So we have, for example, ganun pa rin, a plus b, but you first add, or you first write b, okay, before a. So the result is again the same, no? So we have your b and then a, then you add that, or you connect the tail of b to the tip of a, the result is the same pa rin. Okay, so ganun pa rin yun. So addition of vectors is associative, no? If you have two vectors, so I mean, if you have three vectors to be added, it is associative, no? So ibig sabihin, you can first add the a and b vectors and add c, or you can first add b and c vectors, then a na naman. Okay, so the same pa rin. So the to subtract a vector, so you will just change the uh, sign of the vectors to subtract it. So for example, is yung b mo, just change its sign to subtract it. Okay, so multiplication by a scalar. So multiplication of a vector by a scalar is um, simply as multiplying its magnitude by another magnitude. Okay, so yun lang, no? The direction is unchanged. Okay, only the magnitude is affected. For the scalar multiplication, it is a distributive. No? So if you have an addition of two vectors and it is multiplied by the scalar a, just distribute that one and you will find the final answer. Okay, and the dot product of two vectors is, we have here the dot product of two vectors. So if you have two vectors, their dot product is suggested by this AB cosine theta. Okay, so where theta is the angle between the two vectors A and B. Okay, so here. Okay, if you have two vectors A and B, and between them is theta, okay, we can find the value of scalar product, okay, which is equals to the magnitude of E and magnitude of B times the cosine of the angle between them. Okay, so yun. So take note that the dot product is commutative in this case, no? But okay, so in this case, the dot product is commutative. Okay, so you can have the dot product of A and B, or it is also equals to the dot product of B and A. Okay, same pa rin. So the dot product is also a distributive, no? So if you have an addition of two vectors, okay, then it is dotted with the A. So just distribute that A to the B and C. Okay, so A dot B plus A dot C. So so if parallel, which is theta is equals to 0, A dot B is equals to AB cosine of 0, okay, or it is equals to AB. And if it is perpendicular, which is theta is equals to 90, so your AB, A dot B is equals to 0. Kasi cosine of 90 is equals to 0. Okay, so example. So let C is equals to A minus B. Then calculate the dot product of C with itself. Okay, so this is um, a definition or derivation of law of cosines. No? So you have a C, okay, that is equals to A minus B. Then idat mo siya sa sarili niya. So you have A minus B dot A minus B. So distribute mo lang yun sila. Okay, A dot A minus A dot B minus B dot A plus B dot B. Okay, so simplifying that one, so we have A squared minus 2AB cosine of theta plus B squared. Okay, or it can be simplified as A squared plus B squared minus 2AB cosine of theta, which is the law of cosine. Okay, so dito tayo sa cross product of two vectors. The cross product of two vectors is defined as A cross B is equals to AB cosine of theta and hat, where n hat is the direction of the direction of the resulting um, cross product of two vectors. Okay, so we have n hat is the unit vector whose direction is determined from the right hand rule. No, so for the right hand rule, let your fingers point on the direction of the first vector, yung fingers mo, and curl it around via smaller angle towards the second, then your thumb in direction of the n hat. Okay, so you will point your fingers on the first vector, then curl it to the other vectors, then where the thumb is pointing out, the that is the direction of the n hat. Okay, so yun. So, for example is this one, we have A and B. So, kung i-cross mo yan siya, o kung gagamitin mo yung right hand rule, yung fingers mo is pointing on these vectors A, then yung palm mo is pointing on this vector B, then if i-curl mo yan sila, your fingers will point directed into the plane, no? Directed into the plane. So, just try it, no? Then, another one is yung B and A mo, if you point the if you point the if you point your fingers towards the direction of this A, then curl it towards this B, then your thumb will point will point outward of this page, no? So outward of the plane. Okay, so cross product cross product is distributive, no? So same as for dot product, it is also distributive. If you have two vectors, then it is crossed with the other vectors, so you just have to distribute that one. Okay, but take note, cross product is not commutative, no? It's because if you have a cross product of A and B, it is equals to negative of B cross A. So in short, A cross B is not equals to B cross A, so it is negative of 1. So it means that it's not commutative. So generally, A absolute value of A cross B is the cross of the parallelogram generated by A and B. Okay? So, A and B, okay? If you have these two vectors, no? Okay, and it is the cross of them, and its magnitude is the area of the parallelogram that is formed by two vectors A and B. Okay? So, if two vectors are parallel, that is theta is equals to 0. I mean, yes, theta is equals to 0. Then sine of theta is equals to sine of 0, or it is equals to 0, then A cross B is equals to 0. So it means that you cannot take the cross product of two vectors that are in the same direction. Okay? Okay, so dito tayo sa vector algebra and component form. So let X hat, y hat, and z hat be a unit vector parallel to x, y, z axis respectively. So if you have that one, okay, for example is this one, no? So we have yung x hat natin is pointing towards the x, yung y hat natin is pointing towards y, and yung z hat natin is pointing towards z. Then an arbitrary vector A can be expanded in that direction, okay? Or taking the component of the vector A towards that direction, we can express our vector A in terms of this one. So we have here A is equals to AX, X hat, AY, Y hat, AZ, Z hat, where AX and AY and AZ are the components of A along the unit vectors X hat, Y hat, and Z hat. Okay? So, rules. We have here to add the vectors, add like components. So if you have these vectors A and B that is expressed in component form, and you are asked to find their addition or their sum, you will just have to add the component, okay, separately, okay. And if you have a scalar quantity that is multiplied with the multiplied with a vector a, what you will do is distribute just to distribute the quantity a, okay. So yun. So then to calculate the dot product, multiply like components and add. So if you have a and b, okay, if you have a vector a and b, then you are asked to find their dot product, okay, given that a and b are expressed in component form. So what we will do is just multiply each component, the same component dapat, then add them, okay. So ax plus bx plus ay plus by plus az plus bz, okay. So we have here a proof, so just take a look at that one, okay, how that so we have here the proof of these equations. We have x dot x hat dot x hat dot x dot is equals to y hat dot y hat is equals to z hat dot z hat is equals to 1. Okay? So, syempre kasi as we have said, di ba, pag the same sila ng direction, if you take the dot, it is equals to 1. Pero pag different sila ng direction, if you take the dot, they are equals to 0. Okay? So, yun. So, to calculate the cross product from the determinant whose first row is in x hat, y hat, and z hat, and whose second row is in A in component form, and whose third row is B, okay? Whose third row is in B, okay? So, if you have two vectors A and B, that which is expressed in a component form, then taking its cross product, so you will use this one, okay, you will use this formula, okay, x hat, y hat, and z hat. The second row is ax, ay, and az, and the third row is bx, by, and bz. Then you will just take the calculation for matrix here, then you will find the final answer, okay. So this is the proof of that one, okay. So we have here uh x cross x is equals to y cross y is equals to z cross y are all equals to 0. Take note of that, no? Kasi nga, as I have said here, pag yung dalawang vectors mo have the same direction, their cross product is equals to 0. Okay? So, so and so forth. So, if you assume this and taking this one here, this product here, so you will reduce the value here. Okay? So, we have here triple product. So, for triple product, uh, for the triple product, we have scalar product of A dot B cross C. So geometrically, A dot B cross C is the volume of parallelepiped generated by A, B, and C. So if you will take this product here, their volume or their product is equal to the volume of that volume forming by the vector A, B, and C. Okay, so or you can just manipulate the product of this one by using the rules for cross product and dot product. Okay, so ganun lang kasimple actually. So note that uh, the dot and the cross can be interchanged. Now, for example, if you have here, you can interchange the dot and cross provided that the sequence of ABC is not violated, no? Or it is not or hindi siya nag-iba kumbaga, no? So however, the placement of the parenthesis is critical. Bakit? If you take the parenthesis, okay, uh, to be enclosing the dot product, it is not allowed. No, bakit? Kasi if you first take the dot product of this one, it will become scalar, di ba? So pag yung scalar mo kay cross mo siya sa C, hindi pwede. Okay, dapat magpe-perform ka lang ng cross product if yung dalawang quantities mo are all vectors. So since this is a scalar, so it cannot be crossed to this C here. Take note of that. Okay, so dito tayo sa possession, displacement, and separation vectors. So I think this is understandable naman. Okay, so for the possession, the vectors to a point from the origin of the coordinate system is called as the position vector. So if you have a point, okay, kasi in here we are dealing with a three-dimensional. So if you have a point that is not in the origin, okay, for example, is this one in here outside the origin. So you will take the position vector of that by using this equation. So we have position vector r is equals to x hat plus y hat plus z hat. Okay? So where r is the magnitude of that position vector. So this is given as square root of x squared plus y squared plus z squared. Okay? Or so yun. Okay? So then the unit vector pointing to that direction is given by position vector divided by the magnitude r. Okay? So here. So we have here the infinitesimal displacement from xyz to point x plus dz plus x plus dz, y plus dz, z plus dz is designated or defined by this equation na dl is equals to dx x hat, dy y hat, dz z hat. So later you will encounter the usefulness of this equation. Okay, this infinitesimal displacement. But please be familiarized with this position vector. Okay, for first muna. So we have here the separation vector. If you have a source point and field point, you will find the separation vector of that two point by using this equation. Okay, so we have separation vector is equals to position vector of the field point minus the position vector of the source point. Okay, so yan lang yun siya. So I think that's all. This part here should not be considered muna, no? Please disregard this muna, okay? So once again, this is not my uh, own this is not my own manual or handout, so please don't share this one, okay? Don't share this one. Okay, so this is credited to the original owner. Okay, so please don't share this one. Okay, so this is only for the purpose of learning. Okay, so don't share this one once again. So I think that's all. If you have any question regarding this one, please ask it to me right away so that wala tayong problema. Okay, so that's all. Good day and assalamualaikum warahmatullahi wabarakatuh.